Welcome to today's explainer. We're going to take a simple piece of wood and totally transform it into an ancient scientific instrument that literally tracks the rotation of our planet. I am so excited to walk you through this, honestly, because it perfectly demonstrates how these massive cosmic concepts can actually be measured right in your own backyard. So, thousands of years before we had smartwatches strapped to our wrists or, digital clocks glowing on our microwaves, let's take a second and think about how the ancient Egyptians, Greeks, and Babylonians managed to structure their days. I mean, if you had to coordinate a meeting in ancient Babylon or manage a massive agricultural harvest in Egypt, how did you do it without a screen telling you exactly what time it was?
Well, the answer is brilliantly simple. It just takes a stick, some sunlight, and the Earth's rotation. Today, we're actually going to learn how to harness those exact elements to build one of humanity's absolutely oldest scientific instruments.
Section 1. Building your shadow clock. All right, for your morning setup, you're going to need a straight stick. Anywhere between 30 and 100 centimeters long works perfectly. You want to find a nice flat, open area, maybe a piece of ground or even a large piece of cardboard, that gets direct sunlight all day long, totally clear of trees or buildings. Now, here's the absolute crucial part. Your stick must be pushed firmly into the ground and be perfectly vertical. Use a plumb line or a level if you've got one handy, because a tilted stick will completely throw off your shadow positions. Then get out there nice and early, sometime between 7 and 8 a.m., find the shadow, place a stone or make a little mark right at the tip of that shadow, and jot down the correct time right beside it. Section 2. Tracking the sun. Okay, so you're going to have to return to your stick every single hour to mark exactly where that shadow falls. So if you kicked things off at 8 a.m., you're heading right back out at 9 a.m., then 10 a.m., 11 a.m., and all the way into the afternoon. Consistency is absolutely key here. And as you keep doing this, pay really close attention to spotting the shortest shadow of the day. We'll get into why that matters so much in just a second. By the evening, you're going to see this awesome curve of markers scattered on the ground. Just connect all those marks with a line, make sure they're clearly labeled, and boom, congratulations, you officially have a working shadow clock. And honestly, the best part? You can just leave those markings, come back to the exact same spot on the next sunny day, and use your stick to tell the actual time. Section 3. The cosmic clockwork. To really understand this new clock of yours, we need a slight shift in perspective. You see, from our vantage point down here on the ground, it looks like the sun is traveling over our heads from east to west, casting these moving shadows. But what's actually happening? The Earth is spinning on its axis. The sun is relatively stationary. We're the ones taking the ride. And the mechanics behind this come down to one absolutely crucial number: 15 degrees. Think about it. Our planet does a full 360-degree rotation every 24 hours. Divide 360 by 24 and you get exactly 15. So the Earth rotates about 15 degrees every single hour, which is exactly the movement your little stick in the dirt is tracking. Every hourly mark you made on the ground is literally a visual record of a 15-degree planetary spin. How cool is that? Throughout the day, you're going to notice a very distinct observable pattern. In the early morning, when the sun is super low on the horizon, you get a really long shadow. Same thing in the evening as the sun sets, another long shadow. But sandwiching those two is a very specific, much shorter shadow right in the dead middle of the day. That shortest shadow we just talked about, that marks something called solar noon. It's this vital astronomical moment when the sun hits its absolute highest peak altitude in the sky for your specific location. Because the sun is directly above its path right then, it creates the minimum shadow length of the whole day. Oh, and a quick fun fact for navigation, that shortest shadow points approximately north-south. Section 4. Rules for accurate timekeeping. Now, I want you to treat these precautions like a strict scientific experiment. First off, never move the stick. Even the tiniest bump will completely ruin the accuracy of your time markings. Keep the surface totally flat because uneven ground will distort the shadow's length. Obviously, cloudy days are a no-go since they kind of hide the shadows. Always mark the exact tip, and maybe use stones or paint so a strong breeze doesn't just erase all your hard work. And please, practice sun safety, right? Wear a hat, drink water, use sunscreen, and never ever stare directly at the sun while you're out there taking measurements. For those of you looking to keep time long-term, there's a fascinating twist here, and it's the 23.5-degree tilt of the Earth's axis. Because of this tilt, the sun's path across the sky actually shifts as we orbit the sun throughout the year. That means the exact path of your stick shadow will change slightly from summer to winter. Ancient astronomers figured this out way back when, and now it's something you can observe for yourself. It really is incredible to think about, isn't it? Such a basic tool, just a piece of wood and some sunlight, and it connects us directly to the grand scale of the cosmos. By tracking a simple shadow, you've measured the rotation of the Earth and observed its planetary tilt. Which kind of leaves us with this final question. If a simple stick in the dirt can track all of that, what other cosmic mechanics are playing out right in your backyard, just waiting for you to notice them? Thanks so much for joining me on this explainer. Keep looking down at the shadows and keep looking up at the sky.